This video is going to be on the section 1.3 notes, which is on collecting sample data. So the way we collect data is extremely important to the validity of our results. If data is obtained in a biased manner, it may be completely useless because it's not going to give us results that are truly unbiased about the population if it was obtained in a biased way. So there are two ways that we often collect sample data. One is in regards to observational studies, the other is in regards to experiments. So an observational study is one where researchers simply observe and measure specific characteristics without modifying the subjects being studied. You can imagine this as like the researchers behind a glass wall and they're just watching and they're taking notes and they're seeing what's happening, or they've found some data after the fact and they're looking through those files or they're looking through those patient records and they're gleaning what they can from that. An experiment is where researchers observe the effects of a treatment on the subjects. And so you'll often see the subjects broken into multiple groups, and there will be some sort of control group where either they're not getting a treatment at all or they're getting a treatment but it's going to have the placebo effect. And so it's a treatment that's like a sugar pill or something if you're doing a drug trial where they're not actually getting the drug, they're getting a sugar pill instead. And so any effect that they have from that is not really from that medication. So there would typically be some sort of control group so you can see what happens without the treatment and then what happens with the treatment. That's generally the case with an experiment. So let's look at a few examples. For every situation, determine whether the research conducted was an observational study or an experiment. So first, the muscles of men were 10 to 15% stronger after they participated in a 10-week high-intensity resistance training program 4 times a week. So here, this would be an observational study. We have no reason to believe that the men were broken into groups and there was a control group that did not get this 10-week high-intensity resistance training program while the other group did. They also were not told to do the training program. They were just doing it, and then somebody came in after the fact to see how effective it was. Number 2, to research the effects of dietary patterns on blood pressure in 459 subjects. The subjects were randomly assigned to 3 groups and had their meals prepared by dietitians. Those who were fed a diet low in fat and cholesterol lowered their systolic blood pressure by an average of 6.7 points when compared to those who were fed the control diet. So this is definitely an experiment. They mention groups that were fed a control diet and then groups that were prepared meals by dietitians. So you definitely have an impact there of the researcher is giving a different treatment. So they're trying to see the effect of the diet that's low in fat and cholesterol. So this is an experiment. Number 3, pharmacists at a major pharmaceutical firm investigated the effectiveness of an herbal compound to treat the common cold. They exposed each subject to a cold virus and then gave the subject an herbal compound or a sugar solution known to have no effect. Several days later, they assessed the subject's condition. This is also an experiment. So the researcher had 2 groups, one group that got the herbal compound, one group that got the sugar solution. They had an impact in the treatment. Number 4. In 2001, a report in the Journal of the American Cancer Institute indicated that women who work nights have a 60% greater risk of developing breast cancer. Researchers based these findings on the work histories of 763 women with breast cancer and 741 women without the disease. This would be an observational study. So from the sounds of it, the researchers didn't plan an experiment. They didn't have a control group and a group that got some sort of treatment. They just took some data that they had. They had the work histories of women with breast cancer and women without, and they looked to see what their risk of developing the disease was based on the records that they found. So that's an observational study. All right, next we're going to look at sampling plans. This is also known as experimental design. A sampling plan is the way that a sample is selected. So the first is a simple random sample. And a simple random sample is one where all individuals in the population have the same probability of being selected, and all groups of the sample size have the same probability of being selected. Next is stratified. This is where the researcher divides the entire target population into different subgroups or strata, and then randomly selects the final subjects proportionally from the different strata. And don't worry, I'm not going to leave you hanging. I will give examples of those because I know that they sound wordy right now. The next one is a cluster sample. This is one where the entire population is divided into groups or clusters, and a random sample of these clusters are selected. All individuals in the selected clusters, are included in the sample. And then the last is systematic. The researcher selects a number at random, n, and then selects every nth individual for the study. So note, perfect random sampling is difficult to achieve in practice. So you'll notice that all of those random samples required access to the entire population, which isn't always possible. And so there are some non-random sampling methods, and these are all going to have some sort of bias in them because they're not random. So the first is a convenient sample. This is where subjects are taken from a group that is conveniently accessible to the researcher. Next is a judgment sample. This is where the researcher chooses samples based on their professional judgment or existing knowledge. The goal is to select individuals who are the most relevant to the study's goals. And I think you can see that bias would definitely be present there. And then the last is a quota sample. This relies on the non-random selection of a predetermined number or proportion of units. Samples are recruited until the quota, that's a typo, until the quota is met. So with a quota sample, you'd say, I need to get 100 samples, and you would just, with the pool that you have accessible, you'd keep getting more and more samples of data until you hit the 100 mark, and then you'd stop. All right, so let's look at some examples. For every situation, identify the sampling plan that was used. So the first one says every fifth person boarding a plane is searched thoroughly. So this is a systematic sample. All the people boarding the plane would be the population, and then every fifth person are the people that are being considered. At a local community college, 5 math classes are randomly selected out of 20 math classes, and all of the students from each class are interviewed. So there are 2 different types of sampling methods that talk about dividing the entire population into groups. The first one is stratified. The entire target population is into different subgroups. The second one is a cluster. The entire population is divided into groups. This one in particular, it says all of the students from each class are interviewed, and that makes it a cluster. When you have stratified, they say they're in subgroups, and you have final subjects proportionally from the different strata or proportionally from the different groups. So that would be if you had all the math classes and you took one representative from each class. Here they're saying there's 20 different math classes, and they're going to choose 5 of them and interview everyone in the class. Next, a researcher randomly selects and interviews 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors at a state university. So this is similar to the last one. They've taken the entire population, all the students at a state university, and divided them into subgroups, and then they've taken proportionally from each of the subgroups. So this is a stratified sample. All right, next, a high school student interviews the first 100 students to enter the building to determine the percentage of students that own a car. So this one, if it's the first 100 students that come into the building, that's convenient to just stand there. You're only going to get students at one time of day. You're not going to see, for example, if you were at a high school and you looked at the first 100 students and you happened to be standing there when the buses arrived, then your first 100 students are probably not going to be representative of the students that own a car. If you're standing there maybe after all the buses arrive and you're waiting for students, then you're going to be maybe by the car lot and the students, you can see the students that are coming. So a convenient sample is what this is, because you're just basically waiting for the samples to come to you. The next one. All the teachers from 85 randomly selected middle schools in the United States were interviewed. So here we can imagine that the population would be all of the middle schools in the United States. So if we have all of the middle schools in the United States, then each middle school would be kind of like a subgroup of that. And 85 randomly selected, if you interview all of the teachers at those 85 schools, then we would say, then those subgroups, every single person in the subgroup was interviewed. And so this would be a cluster. The name of 70 contestants are written on 70 cards. The cards are placed in a bag and 3 names are picked from the bag. This is just a simple random sample. And remember, that one was that you have every single person in the population. So here it's just the 70 contestants, and every single person in the population has the exact same probability of being selected. Last, to ensure customer satisfaction, every 35th phone call received by customer service was monitored. So the population would be all of the phone calls received by customer service, and then every 35th phone call would be systematic. Okay. Next, we're going to look at the types of studies. So we have a cross-sectional study. Oops, didn't leave myself enough room. This is where data are observed, measured, and collected at a specific point in time as opposed to over a period of time. Next is a retrospective study. And this is where a question is posed and the relevant data is collected from a past time, retrospective, past time period by going back through records. And then next is a prospective study. This is a question that is asked and an experiment is designed before the data is collected from groups that share common factors. This is generally scientific experiments. So next we're going to look at a few different samples and see which one of these it refers to. So if you're analyzing the current poverty levels in America, that would be a cross-sectional study. Because you're not talking over a period of time, current poverty levels would be something that is a specific point in time, that's right now. Next, study the effect of a new drug. This would be a prospective study. You're posing a question, how effective is this new drug? And then you're going to design an experiment and collect data. Next, determine the effect the discovery of the polio vaccine had on the incidences of the disease. This would be a retrospective study. Polio was a disease that was a problem back in time. The polio vaccine was something that is historic, and so you'd be looking back at relevant data that was collected from the past. And last, the percentage of Americans in favor of big government now and in 1900. So when you're looking at the percentage of Americans in favor of big government now, you'd be talking about a cross-sectional study. But when you're looking at the percentage of Americans in favor of big government in 1900, you'd be looking at a retrospective study because you'd be doing research on a past time period.